Hi everyone, I'm Sang Kim. In this video, I would like to show you how to do discriminant analysis by quadratic function. As I mentioned in the previous video, it would be better to use quadratic discriminant function when we can't assume same covariance metrics among groups. I have prepared sample data from this book, and I have selected first 40 samples from Alaska's salmon and first 40 samples from Canada salmon as a training data set. And 10 samples from Alaska and 10 samples from Canada salmon, I have treated them as a test data set. According to this box M test, we can say that these two groups, Alaska and Canada salmon, doesn't have same covariance metrics because we reject null hypothesis. In our program, we can use QDA function for quadratic discriminant analysis. As you can see, the output does not provide linear coefficients. It only provides prior probability and group means. So the purpose of discriminant analysis is to get this predicted group, 1, 2, 1, 1. So this quadratic discriminant analysis prediction is based on posterior probability. So I want to show you how to calculate this posterior probability in Excel. Okay, let's move on. In order to calculate posterior probability, we need to calculate delta x, and based on this delta x, we can calculate posterior probability by using this formula. The meaning of K is group number. So there are two groups, 1 and 2. So in this case, we can think of K equals 1 and K equals 2 for each group means. I have calculated freshwater marines average by using average function. In order to calculate covariance metrics for salmon 1 and salmon 2, in column F and column G, let's enter data, freshwater and marine. So freshwater minus, we can think of VLOOKUP function. Lookup value from column B, comma, and table A, press F4, comma 2, first. And for marine center value, marine minus, same approach, we look up. Press F4, comma 3, first. Right, there are 80 by 2 metrics here, 40 by 2 for Alaska, and 40 by 2 metrics for Canada. Okay, salmon, Canada salmon I mean. So let's get covariance metrics for salmon 1 here. So finally we need to calculate 2 by 2 outputs here. So in Excel we can consider mmert function for matrix computation. Mmert and transpose from column F to column G, and this is for group 1 data. Okay, right, and then again select same data here, right, and then Control Shift Enter, right, and then we need to divide it by 39 because there are 40 samples. Okay, cool. And this one is for inverse matrix for this part. So M inverse. Okay, Control Shift Enter. Okay. For covariance, salmon to covariance matrix, same approach, mmert transpose from group 2 here, group 2 data, and same data. Okay, and over 39. Okay, then let's press Ctrl Shift Enter. Right, this is covariance matrix for segment 2. And then the inverse matrix, you can use inverse M-inverse function. Right. All outputs are ready to calculate delta 1x and delta 2x. So for column H, it means fresh water minus mu1, this one. Okay. So again, same approach. We can select age group by using column B information. Okay. Sorry. So for column H and I, we want to calculate delta 1x for all data. So we need to use same average, right, for delta 1. So fresh minus group 1 fresh 1 average, and marine minus group 1 marine average. Okay. Yeah. So for second group, we want to calculate the delta for group 1 average. Okay. So it means this is the distance, yeah, from group 1 average for all data. And for column K and L, this is the distance from between raw data to group 2 average. All right. So D1 score, this one. Minus and merge x minus mu transpose. Actually, this 1 by 1 value. So this is 2 by 1, 1 by 2 vector. So we don't need to transpose it. This part we need to transpose it. Okay. This one. And sigma inverse from here. Let's fix it because we need to apply this formula for other cells. Okay. And again, emerge matrix computation, comma, transpose. This one. Okay. And over 2 here, and minus log of determinant sigma 1 here, press F4, okay, and over 2 plus log of prior probability, which is 0.5, right? Then let's press Ctrl Shift Enter. Okay. So we can apply this formula for other cells. Okay. Let's get value for column K and L. So as I explained to you, fresh water minus group 2 average, this one, press F4. And marine minus marine average for group 2 here, press F4. Right. So delta 2 score, same formula, and merge minus and merge this part, and sigma 2 inverse, this one, let's fix it. Okay. And emerge sigma and transpose. Okay, and over 2 minus log of m determinant covariance matrix from group 2, press F4, over 2 plus log of prior probability, which is 0.5, okay. And Control Shift Enter. Right, so double click it, we can apply this formula for other cells. Okay, the final step is to calculate posterior probability. So by using this formula, so exponential delta 1 square over exponential group 1 plus exponential delta 2 square here. Alright, so as you can see, same. So let's double check. Okay, this is the first 5 posterior probability for these 5 data. So as you can see, we were able to get posterior probability by using this delta calculation. Again, group 2 posterior probability can be calculated by 1 minus group 1 posterior probability, right? Because the sum of each group's posterior probability is equal to 1, right? So that's it for today. So today I wanted to show you how to get posterior probability when you do quadratic discriminant analysis. I hope it was useful for you to understand how to do quadratic discriminant analysis and how to get posterior probability. Please click like and subscribe if it was useful for you. Thank you.